Okay, so we'll begin. Today we're going to be going over 2C, and the whole chapter is called the chain rule. And there's two parts to it. There's 2C.1 and 2C.2. We're going to do it over I'm going to teach three things. Okay, so up here, we'll do this. This will take about 4 minutes, and then we'll spend probably 5 minutes doing the exercise 2C.1. Short one, skill we've done in year 11. And then we'll have a look at C.2. We're going to look at a long method to understand the process involved in it. And then we're going to look at a really short formula right at the end of the lesson that we can use to crunch out these questions. So what we're looking at to begin with is what we call composite functions. And the word composite gives it away. Composite. One function composed of another function. So if we have, this is the function f of x, and this is the function g of x, and we are asked to find f of g of x, all right? Remember, with function notation, if we were going to find f of 2, what that means is you put the number 2 everywhere there's an x in the f of x function. If we're going to find f of g of x, we're going to put the g of x function, that whole thing, everywhere there's an x in f of x. Alright, so f of g of x is going to be 2 times the whole g of x function. That is 3x take x squared. Okay, 2 times the whole g of x function. And then we have this plus 3 hanging out the side here. And we can expand it and collect like terms. We get 6x, take 2x squared plus 3. Okay? F of g of x is going to be this function here. Okay, next we're asked to find g of f of x. So now g is the big function. We're putting f of x into g. So we're going to take the f of x function and we're going to put it everywhere there's an x in the g of x function. All right. So what does that look like? 3 times the f of x function. Take, and then the f of x function squared. Alright, so that's the skill, right? The skill is the substitution to recognise the composition. Now what we're going to do is we're going to expand it and we're going to collect like terms because it allows us to, again, practice distributive law, practice perfect square expansion, making sure that negative distributes. So we're going to do that in a series of steps. We're going to have 6x plus 9, that's what that expands to. I'm going to leave this negative out the front for now and I'm going to use the perfect square rule to expand this. I'll write that up here. Assumed knowledge. A plus b squared is a squared plus 2ab plus b squared. Yeah, that's the expansion that we're performing. So when we expand this one, a squared plus 2ab plus b squared. All right, another way it can be done is using FOIL, right? You can use FOIL, it will take a little bit longer. That's what's good about the perfect square. Okay, I'm just going to simplify it in the brackets here. So 2x squared, notice how the brackets are around it. That whole thing is squared, okay? A is squared, the whole value of a, which means the squared distributes to the 2 and the x. All right, 2 squared is 4. Over here we've got 2 times 2 times 3. We're going to have 6x, and then we have plus 9 at the end. All right, now the negative can distribute, okay? And notice we've got 6x plus 9, take 4x squared, take 6x, take 9. 6x take 6x, 9 take 9, we're just left with minus 4x squared.
How did you get this?
12x, thank you.
Yeah.
Take 12. So we're going to have 6 take 12, we'll have minus 6x take 4x squared. Good. Every now and then I do that on purpose. Every now and then I do it by mistake. That was a mistake. All right. Everyone okay with that? All right, good. So, look, the main skill anyway is the composite functions, the composite of it. Over here in the second question, what we're doing is we're saying, you've now got a composite function. What was the initial f of x and the initial g of x to make this composite function? How did we construct it? So if we're looking here, we have one function inside of another function. So we have to say, what's f of x, what's g of x? So this is one where we're just going to sort of look at it and say that to come up with a solution. So if f of x is x to the power of 5 and g of x is 4x take 3, then we can see that the composite of these functions, f of g of x, is this solution here. All right, so rather than constructing a composite function, we're starting with one and breaking it down into its components. What are the components used to construct this function? All right. Similarly, we can have f of x as 1 on top of the square root of x, and g of x as 5x take 9. Okay, so there's not a whole lot of working out there. Hopefully when I'm writing the answer up, you can see, oh yeah, if I substitute g of x in there, I'm developing that composite function. So this is a skill that we're going to develop by exposure to it. Excellent, so that's 2C.1. Let's make a start on that exercise. We'll spend 5 to 10 minutes doing it.